Hi, in this video, we're going to learn all about composite functions. So when we talk about composite functions, we're really talking about putting one function inside of another. So our notation could be written in two different ways. One is with the little open circle, and the other is what I call the nested format. So if you look at this, in either case, we have f of g of x. This is where g of x is being substituted into the function f. On the other hand, if we had something that looks like this is g of f of x. This is where f of x is plugged into g. So order does matter. Let's take a look at our first example, f of g of x, when f of x is 2x plus 1 and g of x is x squared minus 3x plus 2. So in this case, I'm going to start by rewriting it in its nested format, f with the parentheses, and then inside that is g of x. Now, because it's not f of x, I'm going to replace the x with the g function. So instead of 2 times x plus 1, it's going to be 2 times x squared minus 3x plus 2 plus 1. Now I can simplify it as we normally would by distributing the 2 and combining like terms, which is going to give us 2x squared minus 6x plus 5 as our final answer. Now, do you think we'd get the same thing if we did g of f of x? Probably not, right? Because I kind of already gave that away. So what I'm going to do first, just like last time though, is rewrite it in its nested format. And now everywhere there's an x in the g function, I'm going to replace it with 2x plus 1 because that's my f of x. So now I'm going to have 2x plus 1 squared minus 3 times 2x plus 1 plus 2. Notice that when I have 2x plus 1 squared, I'm really doing 2x plus 1 times 2x plus 1. When I multiply that out, I'm going to get 4x squared plus 4x minus 1. Then I distribute the negative 3, and I get minus 6x minus 3, and I carry down my plus 2. My next step is to rearrange it so that everything is in order from largest exponent to smallest. That makes it easier for me to then combine my like terms. So I end up with 4x squared minus 2x when I do g of f of x. So as you can see, it is definitely a different answer than when I did f of g of x. And that is how you work with composite functions.